Hi everyone. Today we received a request from one of our subscriber that he wants to do a simulation for finding the integral for two of the function as shown here. The first integral is minus 2 to 2 e raised to power x plus x square. So how would we do this simulation in Excel? So today I'll show you how we can do that. Before doing that, I'll just give you a small uh, tutorial on what the integration is all about and how simulation is used. So suppose if I have a function y is equal to x, then if I plot this function, it will look something like this, and this is y and this is x. And if I want to do an integral of this, then this will look something like that, x dx 0 to 2. So in that case, what I'm asking is that I want to calculate the area under the curve from 0 to 2. So if this is so I want to calculate the area in this region. So if I do the integration here, integration will look something like that, x square by 2, 0 to 2, or that will be equal to 4 square, oh sorry, it should be 2 square divided by 2, and that will be equal to 2. Another way to do this same thing is to just look at this triangle, and this is 2 and this is 2, so this is the area of a triangle. So area of the triangle is equal to half into base into height, so that will again give us 2, right? So the third approach to do the same thing is by simulation. So what the simulation do is that it takes y and it multiply this by dx and then takes the sum of it. In that case, the dx should be very small, right? So if you look at the integral, so suppose if I have a line here, so in that case this is called dx and this is y, right? So if I calculate the area, I have to calculate the area of the strip. So if dx is very small, this strip can almost be considered as a rectangle, and the area of a rectangle is equal to y into dx, where dx is one of the side here and y is the another side, so that's almost equal to a rectangle. So if we add all these rectangles together, then we'll get the area. So I'm using this approach to calculate the area of this function, and then I'll use the same approach to calculate the area which our subscriber has asked for. So let me begin in Excel. Now we are in Excel. So suppose if I am want to do integration from x1 and x2, so x1 is suppose is 0 and x2 suppose is 2, and we want to calculate first the dx. So how small we want to go for dx? So let's say that we divide this range into 500 equal distances. So in that case, I'll say x2 minus x1 divided by 500. So now dx is very small, it's 0.004. So now let's say that I now simulate x. So my first because I start with x1, so I'll say that my x is x1, which is 0, and then the next x or next increment would be x1 plus this dx, and I'll put a dollar sign here because when I drag the cell down, then the reference for this cell will not change. So now if I, you can see that if I drag it down, there is a increment from 0.004 to 0.008, and if I click on this, then reference is still the same. However, the reference A7 has changed because there is no dollar sign here. So now I can do the same thing, and I keep dragging it, and so you can see that I just need to reach until um, 2. So now you can see that I have reached 2 here, and you can see the number is 506, and I started with 6, so there are total of 501 points. So now if I calculate y, so because our first equation which we want to try, let me say insert here, and the uh, equation is uh, y is equal to x, right? So in that case, if I put y is equal to x, so I just need to say y is equal to x, and then double click here, so I get x and y, and then I can plot these two functions together. And this is how I get the same line as I showed before. And now to calculate the area, all I need to do is add all the y's together and then multiply by dx. So the answer should be equal to sum, and then add all of these together and then multiply by dx. So that's my answer. So you can see the answer is, so answer is 2.004, which is very close to 2, which we calculated theoretically. Now let's go to the request question. So if we go to the request question, that was why, so in this case we start with the problem A. So x1 is -2 and x2 is still 2, and then the equation changes to something else. So in this case, y is equal to exponential of x plus x square, right? So that's all we need to do, and then double click on this one, and now you can see that this is how the equation looks like. And if we calculate the area under the curve, that should be our answer. So it is that simple. Now let's go to the problem 2. The problem 2 is little trickier because here it says that x1 is 0 but x2 goes to infinity, and we don't know what that infinity means. So let me keep it to 2 right now, and let's see what we can do. So here I'll say y is equal to x into 1 plus x square raised to power -2, right? So if I do this and then double click on it, and now you can see that this is how the equation looks like. So now because it goes from 0 to infinity, let me try putting 5 here. So if I put 5 here, then you can see that our curve is approaching 0. Again, if instead of 5 I put 10 here, then it further approaches 0, and even if I put 100 here, then it goes to approximately 0. So you can see that the answer is not changing. If I put 100, it's 0.49659. If I put 20 or not, sorry, if I put x2 as 20, it's 0.49862. So it is still approximately same. So we can safely assume that the answer for this should be if we round off, it should be zero 0.5. So in that case, it doesn't matter. For simulation, we can either go to very high number, or still we can only do it simulation until 20. However, be cautious here, because if you put a very high number for x2, like suppose if I put this high number, then my number will change here, because my dx is very different. So because dx is different, it straight away goes from 0 to then 6000, and you lose all the simulation which, or all the area which you need to calculate around 1, because you can see that the peak was around 1. So you can't do that in this case, so we have to be careful in that regard, right? So I hope this tutorial help, and if if anyone has more request, they can always submit that request to me by my email, or just leaving a comment on the under the video, and I'll try to help in that case. Thank you.